Today we are joined by Teledyne Esco's Cashel Trivedi, our business development manager on the water platform, and Steve McManus, senior product support specialist. With that, I would like to turn it over to Cashel.
Good morning, good afternoon, wherever you are. Thank you very much for joining this presentation on PFAS sampling strategies. Before I start my presentation, let me talk about history of our company, Teledyne ISCO. Teledyne ISCO was formed in 1958, and in 1971, we invented the first automatic wastewater sampler. It was very timely because the Clean Water Act in United States came in 1972. And since then, we are currently the leader for automatic sampler worldwide, and our business is progressing well. So that's about, we are located just now in Lincoln, Nebraska. From 1958, we are here in Lincoln, Nebraska, United States. So in today's presentations, we will be focusing on sampling for PFAS, and our agenda will be that we will discuss a background of what is PFAS, what is the chemicals and why it is, what are the concerns, environment concerns, health concerns we have. Then we'll be talking about what are the sampling basics and what are PFAS sampling requirements are. And PFAS is very sensitive, so what care needs to be taken at site while collecting the samples, and how to collect the samples and how to handle those samples. So these are the topics that we will discuss today. So as PFAS is a new subject for many people, we thought of defining what is PFAS means for those who don't know what is it. So PFAS is nothing but it is a carbon and fluorine compound together. It is that compound is very persistent and does not easily degrade. That's the biggest worry or the danger we have, that it's very persistent. It is also bioaccumulative. That means it builds up in a living tissue and that impacts biological health. The history wise, it is basically in 1938, DuPont developed PTFE, that is called as a Teflon, that was invented in 1938. And after a decade or so, there was a mass production in cookware. It started getting used in cookware. There was a mass production. And 5 years down the line, 3M company came up with a product called Scotch Guard, which is basically water and stain repellent chemicals, which is also using this compound, which is carbon and fluorine compound. So this carbon and fluorine compound, if I look at the chemistry, they are chained, but then, that chain is also connected with some other in the front, which is in kind of either it can be carboxylate or phosphate group or sulfonate group. So it can be different way. It is that chain, carbon and fluorine chain is connected to different. So then it forms a PFAS or PFOS, PFOS, or those kind of things. It's depending on the where it got connected. But here you can see that the carbon and fluorine compound chain is hydrophobic in nature. And hydrophobic is basically, it repels the water. Whereas the head side, which is either it is connected to carboxylate or phosphate, they are generally hydrophilic. So which is like having a, it can mix into water. The one side, so the tail side is repelling the water and the head side is repelling oil. So both property together is creating water and oil repellent, and that is suitable for many many products. And as because it is like hydrophobic and hydrophilic, the head always remain in the water, whereas the tail remain outside the water, so that there is a surface between water and air. That compound stays there, and that's a reason, since it has a property of repelling water as well as repelling oil, it is used in cosmetic, where you don't want the water to come in. They use in a rain jackets, where you want to repel the water, tents. You want to use it in cookware, where you want to repel the oil. You don't want the oil to get absorbed. So that is the reason it become very popular and started getting used in a multiple places. So it is basically, it's a PFAS stand for per and polyfluoroalkyl substance, and there are many substance uh, are there, but we're going to focus today on PFOA and PFOS and GenX. Why we are focusing on that? Because current EPA guidelines or all the process are based on these three compound. That's why we will be focusing on that. So these three compound is basically either linear 8 carbon chain with a different head we talked about, or it's a branch chain. So depending on the type of compound, you have a different chemical compositions. It is used in formally used, as I mentioned, that DuPont's PTFE used in cooking ware, as well as in where you are using for the carpet on the oil resistance material. So because PFAS is persistent, does not degrade, it started creating health issues and environment issue. And we will talk about what are the health issues are there and what are the environment issues in a subsequent slide. But because of that, PFAS came into news very much. You can see here the quote from Washington Post, and people started understanding the danger coming from PFAS, and that's why in there was a class action lawsuits in 2017, and it was represented by 70,000 people. You want to know more about it, you may want to watch this movie, Dark Waters, which came out in 2019. This all based on PFAS. So this is all about history of PFAS, or the background of PFAS. Now let's talk about the source, where we are getting PFAS. The PFAS is everywhere. PFAS is in shampoo, paints, non-stick cookware, stain resistance product, firefighting foams, everywhere. The PFAS is there. We started using this compound without understanding properly and the concern, and we used everywhere, and it is very difficult to control their usage in our current lifestyle. So the industrial source, if we are looking for the industrial source, it is in a textile or leather industries. When the consumer applied the coating to repel the water or oil, as we explained, it has a property to repel water or oil. So we use this kind of things in textile, where we are, in the clothings or carpets or outwears and those kind of things we are making. That's where the PFAS materials are used. Paper products, because the surface coating, we try to eat our fast food, fries where you eat, you have good food packets or food wrapping, which, they don't want oils to get absorbed. So we use those kind of coating, and that coating is PFAS. Metal plating, sometime you want to enhance the product appearance, or you want to, do the corrosion prevention. We do the plating everywhere. That's where the PFAS, the material that you use, contains PFAS. And like the resins, molds, and plastics and kind of stuffs are there. So we are using PFAS everywhere, or these are the industrial source where the PFAS are generated and discharged to environment. So this has created a lot of environment concerns because PFAS do not break or do not break down in the environment. And it can move also through solids, not just water. It can also move through solids, and it can end up in a groundwater or any of the water source. It also build up in a fish or wildlife. So when you consume those kind of fish, you inherently get PFAS through those food. So we get exposed to PFAS in multiple ways. If we are, if there is a drinking water source is contaminated, then the well is there. It's a contaminated water. It's close to the PFAS source. We may get by drinking that water, we consume PFAS. As I mentioned, eating fish caught from the water, contaminated by PFAS, we consume PFAS that accidentally with the kids, and they go and they swallow the sand or soil, so they get PFAS if there is a PFAS presence in those solid food grown close to the PFAS, places where they made by PFAS. Yeah, that is also, as I mentioned, food packages, that use also the coating material that can also, that is a source of PFAS, and or we get exposed to PFAS that way. And stain resistance material, we talked that also. When we get exposed, it creates a lot of health concerns. And health concerns is like everywhere you can see it can cause breast cancers, liver damage, kidney cancers, a lot of things are there. And even if the baby is not born, it can delay the mammary gland development in babies. It can reduce response to vaccine. So you can see that, PFAS is creating very big health concerns as well as environment concerns. As a result, EPA has now become, they came out with the guidelines, and they are very strict in implementing the guidelines as well as the limits for each of the compound that we talked about. That four compound we talked about, PFAO limit is 0.004 parts per trillion. Such a low limit, which is very stringent and very sensitive. And same thing goes with PFOS. It's also all these limits you can see, it is in a part per trillion. And it is sensitive as well as it is available in environment, and very where, where you try to take a sample to measure PFAS to this low limit, you have to be very careful and how you take the sample. Otherwise, you will contaminate the sampler, that sample that you have taken accidentally, very easily. And since the limit is so small, you have to be very, very careful in sampling the water. And that's the focus of this today's webinar, that what all care you need to take about sampling. When you take the samples, what all care need to take. But before we dive into the sampling, I just would like to know that depending on your jurisdictions or area of application, EPA has developed different methods. So depending on, let's say if you're dealing with drinking water, you should follow the EPA method 533, 537.1. These are the different methods. And each method define that what all number of PFAS it can detect. As I mentioned, there are many PFAS are there. So for an example, 533 and 537 is detecting 14 PFAS, whereas 537.1 detects 18 PFAS. So number of PFAS EPA started adding to their list. And for the wastewater side, or non-potable water wastewater side, EPA 1633 is used, where it can detect up to 40 PFAS. So there are different methods. So depending on your application, you should focus on those methods and do the sampling for those methods. So this is all about PFAS history, and PFAS defines PFAS chemistries. I would like to invite now Steve McManus to discuss about sampling, how you should sample, what care you need to take, uh, and he will start with what are the sampling basics. But I will invite Steve. Steve is with us for a long time, and he's expert, application expert, product support expert from our side. Steve, you're welcome.
Thank you, Kaushal. I would like to take the opportunity to thank everyone for joining us today as well. We all have things that keep us busy in our daily life, and we appreciate you taking the time to share your time with us today. As indicated, my name is Steve McManus. I have worked for ISCO now going on 39 years. I work in the product support department, and I assist customers on a wide variety of sampler and flow meter products, which can include but are not limited to applications, interfacing with other devices, data and results analysis, and a variety of other product-related support needs. So how does one identify if there's PFAS present in your source of water? Well, it begins by collecting samples. There are two options for sample collection in the field. The first one is a manual or grab sample that utilizes typically a bottle tied to a pole or affixed to a pole of some sort that is then lowered into the source where the water is collected. The pros with the grab sample is initially it's a much lower cost approach to sample collection. The cons are that it has a dramatically increased risk of PFAS contamination for all the reasons that Kaushal has mentioned in his portion of the presentation today. It is less hygienic because the person collecting the sample is in near to direct contact with the sample source. It can be very time consuming because it requires an individual to travel to the various locations to collect that sample. There is variation in sample collection because a person, much less multiple people, may have variations in how they collect that sample, how low they go into the flow, where they orient the bottle, or they to the side, in the middle, and so forth, and that can create variability in the sample analysis results. It also represents a singular moment in time because the individual is not going to park themselves at a location for a very long time, much less a total day for sample collection. So the sample that is collected is only representative of the conditions at that moment in time. The other method is with an automatic sampler that you push the button and it does its sample collection over a longer period of time. It is far more hygienic because only the sample intake tube, pump tube, and bottle therefore are in contact with that sample rather than the individual. It is much more efficient. It's quicker because you have your program set up. You start the sampler and you walk away and it does its thing. It is far more consistent in its results because it is consistently collecting that sample from the same location in the source, and therefore you have a much more reliable sample being delivered to the bottle. In the short run, its initial cost is higher. However, in the long run, because of the higher quality of sample results, the cost becomes more effective and in the long run may be actually far less in cost because of more reliable sample analysis. Independent studies have found that composite samples are superior to grab samples for a variety of reasons. A December 2022 study in the Environmental Science and Technology Water publication found that composite wastewater samples pieced together from various samples taken over a complete 24-hour period at different stages result in a much fuller picture of the ARG contents than a grab sample collected where and when flow volumes are minimal. An article in the Science Daily, day-long wastewater sample yields surprises, reinforces the fact that composite samples far outshine grab samples. There are two basic configurations that can be used for sample collection. There is a composite variation where utilizes a single bottle, where a series of samples over a period of time, typically a day, are collected into that single bottle. The samples are collected at user-defined intervals. A common interval is 15 minutes, 4 samples an hour, which would be 96 samples at the end of the day. Samples in that bottle, therefore, collect the composite of all samples collected throughout that sampling period. And this is currently the most common sampling approach utilized today for this sampling purpose. The other bottle configuration that can be utilized is a multiple bottle configuration, and a 24 bottle option is the most common for sequential sampling, because you can divide up and have each bottle represent an hour of time over that 24-hour period for the day. A single sample or multiple samples are then placed into each given bottle, and again, typically it switches to the next bottle at the end of the hour. Samples are collected at user-defined intervals, typically 15 minutes. And again, bottles are switched upon a user-defined time interval, which again is typically 1 hour. Each bottle, therefore, represents the state of the source for that given time interval that that bottle was representing. And then the next bottle in the next hour, and on down the line. So composite samples allow you to get a lump sum constituents for that day, whereas a sequential sampling approach allows you to track trends over a 24-hour day, which can include a variety of needs such as chemical and biological makeup, as well as PFAS presence over that 24-hour interval. One option for collecting samples, because chilling the sample is recommended for PFAS, would be a transportable refrigerated sampler like the Blizzard sampler that you see here. It is not dependent upon passive chilling, which utilizes ice, but rather active chilling, because there is a refrigeration system in this sampler. The refrigerated samplers therefore eliminate the need for ice or other means to cool a sample, which again results in a properly preserved sample that then will be delivered to the lab for analysis. One of the problems potential with ice, and we'll get into it in a little bit here, is that ice itself can be a source of PFAS, because the water that was used to create the ice could have had PFAS present. So therefore, the active refrigeration in a unit like we see here in front of us is a tremendous advantage. So what are the PFAS sampling requirements? Due to the extreme minute levels of PFAS that we are looking for to detect, great diligence and care is required across the board compared to other sampling purposes and needs. There are two categories when it comes to materials that relate to the equipment out at the sampling location. You have category 1 items, and those are items or materials that will be in direct contact with the sample. Certain materials should not be used when sampling unless they are known to be PFAS free. And this should also necessitate a blank sample prior to use, which we'll get into here in a bit. Category 2 items are materials that will not come in direct contact with the sample, but they will be present at the sampling location. Likewise, these materials should be avoided if possible unless they are known to be PFAS free by collecting an equipment blank prior to engaging in the active sample collection. Items or materials that contain fluoropolymers such as PTFE, which includes the trademark PTFE, otherwise known as Teflon and Hostaflon, PVDF, that includes the trademark Kynar, TCTFE, that includes the trademark Neoflon, ETFE, that includes the trademark Tefzil, and FEP, that includes the trademarks of PTFE, FEP, and Hostaflon FEP. Items or materials that contain any other fluoropolymer are to be avoided at all cost, because they can contaminate and compromise the integrity of your sample collection. Category 1 items would include the pump, the tubing, and the bottles, because typically this is where the water is going to be in direct contact, and you do not want the water to be in contact with sources of PFAS. Items that would be prohibited would be any items or materials containing any fluoropolymer. Potential items which would include some tubing types, valves, pipe thread seal tape, or other similar substances or materials that again can contain PFAS. Allowable materials would include high density polyethylene, HDPE, low density polyethylene, LDPE tubing, polypropylene, silicone, stainless steel, and any items used to secure the samples bottles made from natural rubber, nylon, i.e. cable ties, uncoated metal springs, or polyethylene. Certain items may or may not have PFAS, and therefore it is important to screen in advance to know if a given material is potentially a source of contributing PFAS to your samples. So any items that will come into direct contact with the sample that have not been verified to be PFAS free should not be used, and do not assume that any sampling items or materials are PFAS free based upon composition alone. Some examples of category 1 and category 2 items. For grab sampling, the sample container obviously would be a category 1 because it is going to be in direct contact with the sample, as is the rod or the pole that that bottle is attached to, because again, it will be lower down into the source. If you've done something like zip tied that bottle to that pole, you need to know if the zip ties themselves are a potential source for PFAS. And then if you're transferring that sample to a secondary bottle, you must know if that secondary bottle is a PFAS-free bottle or not. Category 2 items would be For a automatic sampler would be the sampler body. Let me jump back first of all and just cover on the category 1 items for the sampler itself, which would include the strainer, the intake line or suction line, the pump tube, as well as the bottle the sample is being placed into. Then back to the category 2 items, the sampler body, as you see there, the gentleman that's pushing buttons on that sampler, the outer shell of that sampler where the bottles are inside of it, you want to make sure that that exterior and as well as the interior of that sampler is PFAS free, because even though it is not in direct contact, its proximity is enough to suffice to ensure that it is PFAS free. If you're then transferring the bottles out of the sampler and into a cooler for transport, the cooler itself needs to be PFAS free. If you're using ice packs, you need to make sure that they are PFAS free. Any gloves that the individual that is deploying and collecting samples at the site need to make sure that gloves are PFAS free. Any jackets, footwear, if you're wearing waders, any field clothing needs to be, and that would be PPE, needs to be PFAS free. Sunscreen, if you're putting sunscreen on because it's a hot sunny day, many sunscreens are sources of PFAS. That's a big no-no. Any notebooks or pens that are brought to the sampling location may have PFAS. And even laptops or cell phones themselves may have PFAS coatings, as Kaushal was indicating during his portion of the presentation this morning. And so therefore, those should be avoided to be brought into the location of sampling because of their potential to contribute PFAS to your samples. Suggested materials for samples for grab sampling, typically you want an HDPE bottle. A PVC or silicone are also okay. Your rod or your pole that you've attached the bottle needs to be an uncoated, typically aluminum or steel pole. If you have a secondary bottle, a beaker to transfer the sample to, it needs to be HDPE or PVC. Your primary collection bottle should be HDPE. Glass bottles may be used if they are known to be PFAS free. However, PFAS has been found to be absorbed by glass, especially when that sample is in contact with the glass for a longer period of time. So if you're using glass bottles, it is recommended to avoid reuse, single use only. Cable ties need to be natural rubber, nylon, and certainly uncoated metal springs. For automatic samplers, typically your strainer will be a stainless steel or a combination of stainless steel and HDPE. Any couplers for tubing between your suction line and your pump tube, as well as bulkhead fittings, should be stainless steel. The suction line should be vinyl. The pump tubing should be silicone. And you can see our ISCO website for our poster that relates to PFAS sampling, applications, and study on tubing. That's a very good document for review. Collection bottles should also be HDPE or polypropylene. Equipment should always be decontaminated before being brought to the site. Substances that would be prohibited as part of that process would be Decon 90 or PFAS treated paper towels. If you're using them to wipe down, what you're doing is you're basically spreading PFAS on the surfaces of your equipment. and therefore that should be avoided. Allowable substances would be alkanox, liquinox, or citrinox. The equipment should be triple rinsed with PFAS-free deionized water and wiped down with cotton cloths or untreated paper towels. If you're using municipal water, tap water, you might need to screen your water in advance to make sure you're not, again, contributing PFAS from that tap water. Recycled paper towels or chemically treated paper towels, again, may be sources of PFAS. For category 1 items, such as your bottles and your tubing, a recommendation is to actually replace the bottles and the tubing after each use. It's not a requirement, but it is recommended because there could be PFAS being deposited in the tubing and in the bottles. And then if you go out for a second round of sampling, now you already have a baseline of PFAS in the materials that are in contact with the sample itself. Field sampling equipment used at multiple locations can become highly contaminated with PFAS, and so decontamination procedures should be implemented to prevent cross-contamination from one site to the next, especially between individual sampling locations. Sampling equipment can be scrubbed using polyethylene or a PVC brush to remove particulates. I previously mentioned blanks, and the vital importance of blanks are to be able to understand what the baseline PFAS potential is from the equipment itself. So the purpose of an equipment blank is to detect any contamination in the sampling equipment prior to sampling. What to use as part of that is PFAS-free water. And what you would do is run PFAS-free water through that sampling equipment. Just run the pump and allow it to draw that water up and through the tubing and into the bottle. And that should be done, or can be done, in the lab or the field. And then that bottle then would be sealed up immediately after it is collected to be delivered to the lab to determine if the equipment was presenting a baseline PFAS to the samples. Then there is a field blank. And the purpose of the field blank and why it's required is to allow identification of interferences, sources of interferences or potential for contamination that is introduced during the sample collection period and handling on site. Again, what you would use is PFAS-free water, and you would bring that PFAS-free water into the field and then transfer it from the bottle that you transported it out to the field in to another bottle. And again, immediately seal that bottle after doing so. And the purpose of that is to identify if there's any sources of contribution of PFAS in the field. Now, if the sampling is being done on drinking water, there is need to add a preservative to that sample. Then the third blank is the trip blank. And again, the purpose of the trip blank is to identify any potential exposure to PFAS as one moves from the lab, the shop where the equipment was gathered, and transported to the field through the variety of temperatures, changes in pressure, you may be going through elevation, the laboratory preparation of the field samples, and laboratory preparation of field samples for analysis. Again, we use PFAS-free water, and we would take that PFAS-free water, prepare it in the lab, travel from the lab to the site, And then that sample again gets transported back to the lab without having been exposed to the environment from the lab and into the field, and then back. So what care needs to be taken at the site? So first of all, again, secondary sources, category 2 sources, would include clothing that the person is wearing, boots, any rain gear, or personal protection, PPE. Items that would be prohibited would be new or unwashed clothing, because often they have PFAS inherently present as part of their manufacture. Anything made of or containing Gore-Tex or other water-resistant synthetics would be a big-time no-no, because that would be a source of great amounts of PFAS. Anything applied with or recently washed with fabric softeners, sources of PFAS, fabric protectors, including UV protection, again, sources of PFAS, insect-resistant chemicals, again, sources of PFAS, water, dirt, and or stain-resistant chemicals. Again, those are all sources of PFAS. Allowable items would be powderless nitrile gloves, well-laundered synthetic or 100% cotton clothing, with most recent laundering not using fabric softeners, materials made of polyurethane, polyvinyl chloride, PVC, wax coating fabrics, rubber, neoprene, uncoated Tyvek. Items that should be screened because they potentially may have PFAS present would be latex gloves, water or oil or dirt resistant leather gloves, any special gloves that are required by a HASP, Tyvek suits, clothing that contain or is coated with Tyvek. Those materials should be screened in advance to know if they are suitable or should be avoided. Food and beverages, as a general rule, should not be brought on site or anywhere near the location. Items that are directly prohibited would be food that is, should not be consumed at the staging location, especially prepackaged foods or snacks, because as Kaushal indicated in his portion of the presentation, those packaging materials are often coated with PFAS for good reason, but should not be anywhere near the sampling location because they can contribute and contaminate your sample. So if it is near lunch and you are consuming food and it becomes necessary to have that quick lunch break, you should position yourself at some distance away from the sampling location, remove any PPE, and after eating, thoroughly wash your hands and robe on with new PPE so you do not have any potential sources of contamination that you would then bring in to the sample location. Those things that would be allowable on the food side that are brought and consumed should only be consumed outside of the direct vicinity of the sampling area. And they would be things like bottled water or hydration drinks such as Gatorade or Powerade. It's okay to have those with you, just do not bring them near the sampling location and create a potential source of contamination. So issues that relate to sample collection. It is very important that you maintain the cleanliness of the bottles that you are placing your sample in. So do not open the caps and remove the caps of the bottles until the last possible moment to avoid dust or fibers from getting into your sample bottles. If it's a windy day, you might want to try to avoid anything that could get in. If there's a lot of dust being moved into the air, you might even want to try to shield the bottles and try to divert the wind away from the bottles with your body as you're opening them up to, again, avoid any introduction of such into the bottle. Sample caps should never be placed directly on the ground during the sampling activity. If the sampling, must set the bottles and caps down during sample collection because of the lack of any other location, make sure that you set the cap in an orientation so the bottle side of the cap, the inside of the cap, is the cap itself is on a clean surface and the bottle cap is up. Cotton sheeting or HDPE sheeting or triple rinse cooler lid would be a good example of a surface that you should use for that need. Do not insert or let the tubing or any of the items or materials inside the bottle itself. Again, that would be a potential means to contribute and contaminate and reduce the quality of your sample. Your hands should be well washed and gloved, and again with PFAS-free gloves. Use HDPE or polypropylene sample bottles with PTFE-free caps. No Teflon liners. At the sample point, if doing grab samples, samples should not be collected from the very top layer because PFAS is expected to accumulate at that water-air interface, i.e. the surface of the water, as Kausha was describing with the heads and the tails of the PFAS molecule. They will collect and be most prevalent at the water surface. For automatic samplers, keep the strainer and suction line at the desired depth to collect samples. Bottles should only be opened immediately prior to sampling. They should not be opened for prolonged periods of time because that opens the door for substances to get into the bottle and again degrade the integrity of your sample. When returning to the field to collect your samples, the bottle should be capped immediately and not again left open and exposed for the same purposes. Samples should be placed on ice within 15 minutes of collection and chilled to a temperature of 42 degrees or less as determined by EPA 40 CFR 136 and PDES. This temperature should be maintained during the collection and through the transit to the lab for analysis. And it's also important to note, if you are using gel packs, many of those gel packs could potentially be sources of PFAS. So ensure that if you're using ice or other devices to keep your sample chilled, that ice is based upon PFAS-free water or that those ice packs are PFAS-free. Nitrile gloves should be changed frequently because as you're working, material is collecting on the surfaces of those gloves. And again, you want to do everything humanly possible to reduce the contamination from these substances, these materials for your sample collection. So after decontaminating the equipment, change gloves. Immediately prior to sample collection, setting things up, change gloves. Each time sampling equipment is placed in or removed from the site, change gloves. Placing the sample tubing into the water, change gloves. After handling any of the non-dedicated sampling equipment, change gloves. After contact with non-decontaminated surfaces, change gloves. There's kind of a pattern there. For field documentation, things that would be prohibited would be clipboards. Often clipboards are coated with water-resistant material, i.e. PFAS, to prevent them from absorbing water and degrading the clipboard itself. So do not bring clipboards. Sometimes notebooks made with PFAS treated paper, PFAS treated loose paper, PFAS treated adhesive paper products. Do not bring any of those on site or have them in any proximity with the equipment at any time. Allowable items would be loose paper, non-waterproof, and non-recycled. Write in the rain notebooks are approved. Aluminum, polypropylene, or Masonic field clipboards are okay in the field. Ballpoint pens, pencils, and fine or ultra fine point Sharpie markers are okay in the field. Items that may need to be screened would be plastic clipboards, binders, spiral hardcover notebooks, all markers not listed as allowable, Post-it notes or other adhesive paper products, again, could contain PFAS. Waterproof field books may also have PFAS, so screening is a necessity for any of those type of items. Sample handling. Sample storage and preservation, again, this would be after the samples have been collected. Items that would be prohibited would be polytetrafluoroethene, PTFE, lined bottles or caps. Allowable items would be laboratory provided PFAS-free bottles, HTP or polypropylene. Regular wet ice, again, created from PFAS-free water. Thin HDPE sheeting. LDPE resealable storage bags, i.e. Ziploc bags, that will not contain the sample media itself, i.e. the water will not be in the bag. Items that need screening would be aluminum foil, chemical or blue ice, again, because some blue ice or gel packs can be a source of PFAS. Plastic storage bags or others than those listed as allowable. Low density polyethylene LDPE bottles. Glass jars, again, that are verified to be PFAS free would be okay, but they should be screened. And again, as it was iterated earlier, not recommended for reuse simply because glass can absorb PFAS. And in glass, short-term storage only, because long-term storage could reduce the presence of PFAS because the glass bottle itself would be absorbing some of that PFAS and thus lowering the amount that is in the water itself. The sample is cooled and maintained at or below 42 degrees during collection and through transit to the laboratory. Regular ice that is, again, verified to be PFAS free should be used to cool and maintain sample at that 42 degrees or below level. Many portable refrigerated samplers maintain temperature above that limit. So if you have active refrigeration, make sure it's able to maintain temperature at or below that threshold. If a remote lab is used, i.e. you're going to have to mail off or ship off the samples should be shipped as soon as possible overnight to ensure that the samples arrive at the analytical lab in the holding time, within the holding time specified by that lab. A cooler with ice packs should be used to keep samples cool, and again, ensure those ice packs are PFAS free. Chain of custody documentation, other forms should be used in a single bagged in LDPE resealable storage bags and taped to the inside of the cooler lid. That documentation is very critical, as it is with most sampling needs. And with that, we're going to open the floor for questions. If you have any questions, as Sharon has indicated, please utilize the Q&A function of Zoom. And with that, I will open the door for any questions you may have. So once again, I'd like to thank everybody for your attendance today. We appreciate you taking the time out of your day to spend with us here. We have a few questions here, and I'm going to try to go through them with a measure of efficiency because I know we all need to get back to our regular duties. The first question was, will the slides be available after the presentation? As Sharon indicated at the very beginning, this entire presentation has been recorded and will be posted, and there will be an email that will indicate when that posting has taken place. The next question here is related to another question down the line, and Kaushal has requested that he be involved with the answering of that. But the question here is, why is the EPA recommending against composites for 1633?
So yeah,
go ahead.
Yeah, so the other question was also mentioning that, as well as related to 1633. So let me answer these questions, and then I'll answer the second question related to 1633. So 1633 is not against of composite sampling. What they are specifically saying in that 6.2 section, that if you are doing it for compliance purpose, they do not recommend composite sampling. And that is because compliance is on-spot measurement. Composite is generally used over a period, whereas for compliance purpose, they are using any auditing agency, they go and do on-spot measurement. And that's why they do not recommend composite sampling just for compliance. Now, PFAS sampling for PFAS is done for many purposes. It is done for research. It is done for, a lot of equipments are getting manufactured to reduce PFAS. So they want to do sample before, after, and just they want to, some other purpose is they just want to know the presence of PFAS or level of PFAS, not really for compliance purpose. That point, that the same section, it says, if it is approved, then what you need to do is you should try to take a flow-based sampling so that you can get a good representation. If you're just doing for that, you're not, if you're not doing for compliance, you can do a composite sampling, but they are recommending additionally, not time-based, but the flow-based sampling. So that's about 1633 and composite sampling. The second question came in same for the 1633 about HDPE material. Yes, HDPE is so far the best material for bottles, sample bottles. So that is very correct. 1633 highly recommend for HDPE material for bottles. So that's a two question. What are the next set of questions?
I can just go ahead and go on down the list here. The next question was, shouldn't the sample bottle be glass to eliminate contamination? Well, as you heard during the body of the presentation here, glass has the propensity to want to absorb PFAS. And so if we're using glass bottles, especially if we're potentially going to have a little elongated holding time in those bottles, that glass, one, first of all, can absorb some of that PFAS that was in the collected sample and reduce the amount or presence of PFAS in the actual sample. And then if reuse is applied to the bottle, once that bottle has a mass amount of absorption, it could potentially begin to shed that PFAS back into the sample and have the other extreme where now you're elevating the presence of PFAS in your sample because it's taking and some of that PFAS that was absorbed by the glass. So glass generally is not recommended, but if it is used, definitely, as indicated, should be verified to be PFAS free before deployment. And then it's recommended to limit the use to one time only due to that absorption issue. The next question is, does the Blizzard sampler accommodate 24 bottle configuration? The answer is no, due to size constraints. We were not able to implement a 24 bottle configuration for that unit. It does have a 14 bottle configuration, and that is the maximum number of bottles that you can place into a Blizzard sampler. The next question is, what's the difference between LDPE tubing and bottles? Asking because I see your online store that the tubing is PFAS free, but not necessarily your bottles. The simple answer to that is we've had the tubing evaluated. The bottles have not gone through that same evaluation process as of yet. And generally the guideline is preferably to use HDPE bottles due to the more longer term exposure that the bottles would have, i.e. because the sample is going to be in the bottle, as opposed to the tubing where the sample is just passing in and out of the tubing with each sample event.
And we have those HDPE tubes, bottles available. So I think HDPE is as such highly recommended. So that's the reason you should, or we promote HDPE bottle for PFAS sampling.
And then there was an associated question about the strainers and maintaining that the polypropylene portion of the strainer was not indicated to be necessarily PFAS free. Polypropylene, as a general rule, is not a source of PFAS. However, again, as indicated in the body of the presentation with the blanks, it is important to do that field blank, and part of that field blank test would evaluate if any components, which would include the strainer, or are sources of PFAS in that blank. And of course, if you have a baseline beginning to build and show up, change those components. Next question is, I was wondering where we can find PFAS-free equipment, refrigerators, bottles, poles, zip ties. Are there special companies that see it, and how much cost is involved? The general rule there is, as was indicated in the body, certain materials are generally indicated to be okay and considered approved for use in PFAS. Some are questionable and some are outright no, do not use. Again, when it comes to the blanks, that's what's going to be your best option to verify if any of those materials are sources of contribution to PFAS and elevating your baseline PFAS presence above and beyond what the water itself that you're sampling from would contain.
Yeah, and I will say that you will not find one source for all this material. Like zip tie, you should try to find a natural rubber zip tie. That would be good. Poles, you should use stainless steel pole if possible, those kind of things. So you will not find one source for all the materials. But let's say if you are buying automatic sampler from us, we have identified all material you can get from us, whether it's a suction line, strainer, pump tubes, bottles, everything PFAS free material, you will get it from us. But for zip ties and poles, you may have to go for a different source.
Correct. Next question, do you have any example sampling plans available on the Teledyne website for PFAS sampling? The PFAS section of our website is intended to be an ongoing, evolving source of information related to PFAS sampling. So what you see there today is not going to be the end of the line. We will continue to add, contribute to, and modify and update that section of the website as information becomes available to the market in general. So right now, as far as specific sampling plans, there isn't anything on there above and beyond some of the details as we just covered in the body of the presentation here about the practices and approach and materials, et cetera, et cetera. In regards to laundering of clothing to ensure it is PFAS free, since fabric softener is problematic, are dryer sheets also a problem, or are they allowable? I'm going to say right now, I have not seen or read anything that related to the appropriateness of dryer sheets. I would therefore probably lean in the area of cautiousness and just suggest that we don't use dryer sheets, just simply because it is unknown. And the safe route is, generally speaking, the best route to take when it comes to PFAS sampling. As you saw in all those slides, there was always the maybe a section of the allowable where it was recommended that you test those out. And I can deal with a little bit of a scratchiness on a shirt or a pair of pants. So I would say just avoid the dryer sheets for now. We are looking for cross-contamination between waste and stormwater, we are taking samples from the stormwater pipes. Just generally speaking, I'm going to say that the practices for stormwater would be almost identical to the T for wastewater. You certainly wouldn't want to bring any source of PFAS on site. You would want to take all the same decontamination procedures. You would also want to take all the normal practices to avoid bringing anything that is a source of PFAS, food, into the area. So I would say treat the two specific application needs, stormwater or wastewater, the same for now. Let's see here. Has there been any proven contamination or lack thereof from nitrile type gloves? Somewhat of a, in that vein of, you might want to check before you test for certain. But
so far, I think nitrile gloves are allowed for
correct.
While doing the PFAS sampling. Yes.
Correct. And as was indicated in the presentation, limited use and then change gloves. Don't keep the same glove on throughout the entire process, because as you're doing your activity, you could be potentially collecting sources of PFAS on the surfaces of those gloves. So change frequently, and especially at every stage of the process.
I'll take the next question. Is there a holding time that has been determined for PFAS samples? So that is, yes, it is determined, but it all depends on the method, EPA method that you are following or your lab is asking you to follow. For example, that method 533 is defining holding time as a 28 days. 537 is 14 days, but during this whole time, they are very strongly recommending that sample must be stored below 6 degrees centigrade, and there should not be direct light or exposed to light. That's what they are recommending. So depending on the method, yes, the holding time is defined. Yes.
Okay. The next question, shouldn't PFAS be treated like oil and grease sampling where the analyte is known to adhere to the wetted surface, or as we call it, the air-water interface, the surface? Generally speaking, what we're talking about for our sampling practices here is trying to determine how much PFAS is in the main body of water. We know we are going to have an elevated presence at the surface that may not truly represent what is in the water below that's been mixed up in solution. And so therefore, for the needs that we're talking about here, we're more interested in what's below the surface, not so much at the surface where we know there was going to be an elevated amount of PFAS, just simply because that's where it will typically migrate from. Now, that's not to say that 2 months, 6 months, a year down the road, the guidelines that are given to us by the EPA may not, adapt and evolve and start to take a, more deeper look at what the surface quantities are. But for right now, we're talking about the PFAS that's actually mixed in the water and flowing along and hasn't already migrated to the surface. Let's see here. What level of treatment of laboratory water is recommended for laboratory blanks, field blanks, yada, yada, yada? This probably relates to that PFAS-free water comment that was repeated on numerous occasions throughout the presentation. I would say communicate with the analytical laboratory and get their recommendations of where to obtain PFAS-free water. They may even have the ability to supply that on their own, because there's probably a chance they're trying to use ultra clean water for a number of their analytical tests as well. So that's where I would probably recommend to bring a question of that nature to. We mentioned vinyl tubing should be used for suction line. Is HDPE acceptable? The only concern I would have with HDPE tubing is that it's probably going to be a little more stiffer in nature. It's not going to like to go around bends as easy as the vinyl line, could be susceptible to kinking and so forth. So from a practical standpoint, the vinyl line is probably going to be more suitable just because of the nature of the beast for that type of sampling. As far as the next question here, it's a lot of clothing is contaminated with PFAS. Sort of certain Tyvek suits need to be screened. Are other suits that one can purchase to be acceptable? Certainly, I would assume that there would be some source that one would be able to seek and find on that. Obviously, Teledyne ISCO is not in the clothing market. So we wouldn't be able to, provide that material product for you, but maybe even the lab that you're using would have a recommendation of certain entities that one could purchase, that type of material, clothing that would be, PFAS free and acceptable for use in this sampling application.
I'll take the next question. How many Blizzard portable samplers do you have in your stock right now? We have a large project beginning very soon. I will, please contact me after this presentation or in the coming days. I will put you to the right person, and I can help you in getting your sampler and expedite your business. I can help you there.
Can you briefly explain how a Blizzard sampler works? I'm going to broaden that and just samples in general. You've programmed the sample to collect, a number of samples at some interval, typically time, but can also be flow paced if you have a flow meter in place. And then the sampler will draw those samples up and place them in the bottle and then purge the line free after the sample has been collected until it's time to take the next sample. The big difference with the Blizzard is that it brings an active refrigeration component into the system rather than having to use ice or gel packs to chill the sampler, chill the sample. The Blizzard sampler does that with the refrigeration system. And that's probably about as in-depth as I would want to get, and given the subject matter at this point in time. And if there are more in-depth specific questions you have, you're always more than welcome to email me with any questions you may have on sampler operation, Blizzard or other models.
I'll take the next question.
Okay.
Yeah, has the EPA or states started requiring any wastewater facility to test for PFAS? I will say yes. A lot of states have started on their own. For example, Michigan, Arizona, California. Those states have started, doing this kind of or requiring PFAS testing for wastewater facilities, but not across the country. But yes, some states have started that initiatives.
Good answer, Kaushal. All right. The next question, is there a listing somewhere of certified labs that analyze for PFAS by method? I can't tell you if there is such a list out there. I would certainly communicate with it, whatever analytical lab that a given entity is used with.
I think I have a list.
Okay.
I can provide the list, and then the list also depending on the methods. I think the way you are asking the question, yes, by method. So 1633 is a relatively new method. So there are number of labs are not that high. I think it's less than 10. But if you look at 533 or 537.1, there are roughly 50-60 labs available nationwide. And most of the major lab are started doing PFAS testing for those two methods, 533 and 537. But I do have a list and I can provide you the list.
Thanks, Kaushal. Next question is, what do you recommend to keep a 24-bottle portable auto sampler at 6 degrees Celsius or below in summer heat? Obviously, this is a non-blizzard, so we're talking passive cooling using ice or gel packs. Certainly, ice or gel packs would be the means to do that. As was indicated in the body of the presentation, you would want to make certain that that ice or those gel packs that are used are PFAS free. There's certain things that you can do to help that ice do its job is, if you can, position the sampler in some shade to where it's not getting direct sun and increasing the amount of solar heat building up on the unit, which the ice would have to address, and it would cause that ice to melt or the gel packs to melt faster. If you're running a 24-hour sample, use put the ice in the base at the last minute, so that you're not already at some point of a degradation of the quality of that ice right out of the gate. And then if you're sampling for 24 hours, get back to that sampler as quickly as that 24 hours is done, so it's not sitting there further degradation in that ice. Is the Blizzard sampler only for PFAS detection, or can it be used to detect other contaminants or pollutants? Absolutely, the Blizzard can be used for many sampling needs. It's a very common sampler that's selected and chosen to be used in stormwater sampling. So there is no one purpose only for the Blizzard sampler. It could be used in the widest variety of sample collection needs, just as any other sampler model can. So it is not a limited use model of sample. And with that, that's the last question I have here. As is always and often the case, questions may come to mind, an hour from now, 2 days from now, next week. You're always more than welcome to email myself or Kaushal with any questions that you come up after today. And we'd be more than happy to answer any questions that you send to us. And with that, we'll bring this down to a close, and I'll say thank you very much for your time today. We really appreciate you taking the time to join us in this presentation regarding PFAS practices.
Thank you very much, Joe.